Welcome to a new video from our AI literacy series. Do you want to learn more about AI bias? If you think of AI as a well-polished machine, you're in for a surprise. AI is more like a very fast, very confident intern who spent all night reading a library that hasn't been updated since 1950. Sounds a bit too strict? Or you haven't noticed AI serving any biased responses? Well, AI doesn't calculate the truth. It mirrors the messy, biased world we have already documented in our data and hands it back to you formatted as an insight. The model didn't invent the bias. It just automated it. And if your team is using AI for hiring, writing, performance evaluation, marketing, or data analysis right now, at least some of these biases are already in your outputs. Most are going completely unnoticed. So here are the 5 forms to know about, starting with number 1, historical bias. Historical bias is what happens when you train an AI on data from the past, and the past was not fair, which it usually wasn't. So what does the model do when it has imperfect data? Exactly what it was designed to do: find patterns in historical data and apply them to new situations. The problem is that those historical patterns reflect a world shaped by structural inequality, unequal access, and decisions made by people who were themselves biased. The AI learns all of it. Then it optimizes for it. In practice, this means AI systems identifying top talent or ideal candidates based on patterns from a world that looked very different from today's. The model has no way of knowing that the patterns it learned were the product of unequal opportunity, not unequal ability. It just knows what historically correlated with success. Amazon found this out the hard way. They built an internal AI recruiting tool intended to make hiring faster and more consistent. What it produced was a system that had learned to favor male candidates, not because anyone programmed it to, but because it was trained on historical CVs, most of which came from men. The model started penalizing signals associated with women, including references to women's professional networks and organizations. Amazon scrapped the tool. The engineers couldn't be confident they'd caught every discriminatory pattern, so the whole thing went in the bin. That's historical bias at scale, and if your hiring platform is running on data from the last 20 years of your industry, it is learning from that history too. Next is linguistic and stylistic bias. Large language models are trained predominantly on text that reflects dominant language norms. The kind of writing that fills published books, academic papers, and professional documentation. So what does that mean in practice? It means the model rewards a particular style of communication and treats everything else as a deficiency, even when it isn't. Non-native speakers, people who communicate in more direct or informal registers, professionals whose first language shapes how they construct written English, all of them are disadvantaged by this. The model isn't evaluating the quality of their thinking, it's evaluating how closely their writing resembles the dominant pattern it was trained on. Here's an example. Picture a performance review cycle. An engineer who speaks English as a second language submits a report. Bulleted, blunt, highly accurate, gets straight to the point. A colleague submits a 1,000-word corporate speak masterpiece that says very little, but says it beautifully. The AI scores this masterpiece higher. Every time. That's not a meritocracy, that's a styleocracy. And your organization is probably running one right now without realizing it. Research published in 2025 backs this up. AI evaluation systems consistently favors longer, more polished responses, even when shorter answers are equally or more accurate. And the preference for stylistic convention can't easily be fixed through prompt design. The bias is embedded in how these models evaluate, not just in what they produce. So if your organization is using AI to evaluate candidate responses or score customer feedback, here's the question worth asking. Is it measuring quality? Or is it measuring conformity to a particular style of English? Because those are not the same thing, and the model will absolutely not tell you which one it's doing. If you're thinking, we'll just write a better prompt to fix this. Bias number 3 is about to prove why that's not enough, and that is measurement bias. That's one of the harder ones to spot, because everything looks like it's working. Sometimes also called proxy bias, it happens when the metric used to represent success is a flawed stand-in for what actually matters. The model faithfully optimizes for the wrong thing, consistently, at scale, without ever flagging that anything is wrong. The technical performance looks fine. The outputs seem reasonable. The problem is entirely in the question the model was asked to answer. Optum's healthcare risk algorithm is the clearest example. It was designed to identify patients who would benefit most from additional care. Sounds like a sensible goal, right? To do that, it used past healthcare spending as a proxy for medical need. Also sounds reasonable, on the surface. The problem was structural. Certain populations had historically had less access to healthcare and therefore lower spending. Not because they were healthier, because they'd been underserved. The algorithm systematically underestimated their actual health needs and directed resources toward patients who had spent more, not patients who needed more. The proxy was logical, the outcome was discriminatory, and fixing it required replacing the metric entirely, not tweaking the model. And you need a human in the loop to ensure this. The model will never raise its hand and say, "I think the question you asked me is the problem." That's your job. Our fourth item is automation bias. Automation bias is not a flaw in the model, it's a flaw in how people respond to models. Humans have a well-documented tendency to overtrust automated systems. The more authoritative the system looks, the more we defer to its outputs, even when those outputs conflict with our own judgment or expertise. In professional settings, this shows up as AI-generated reports being approved without review, AI-assisted recommendations being accepted without scrutiny, and errors that a trained professional would ordinarily catch being missed because the presence of an AI output shifts the mental frame from "evaluate this" to "confirm this." IBM's Watson for oncology is the example that should make anyone using AI for high-stakes decisions sit up a little straighter. Watson was designed to recommend cancer treatments by processing clinical literature and patient data. Evaluations found that the system sometimes produced recommendations that were unsafe or inconsistent with expert clinical judgment. More significantly, clinicians in some settings gave undue weight to Watson's suggestions because they came from a high-profile AI system with apparent authority. Experts who would have questioned the same recommendation from a colleague accepted it from a machine. That is automation bias. And bias number 5 is representation bias. When an AI system is trained on data that doesn't reflect the diversity of the real world, it performs well for the groups that were well represented in the training data and poorly or harmfully for everyone else. For example, research published in 2024 and 2025 examining image generation models, including Stable Diffusion, found consistent patterns. When prompted with roles like CEO, engineer, or doctor, the models disproportionately generated images of white men. Prompts for assistant, housekeeper, or nurse skewed toward women and people of color. The models had learned the statistical distribution of who holds which roles in documented human history, and they were reproducing it faithfully. The bias is in the data it learned from, and the only way to catch it is to have someone looking for it. But these biases share one thing. None of them are visible in the model's outputs without a person who knows what to look for. The tool will not flag its own bias. It will produce the output, format it cleanly, and present it with exactly the same confidence it would if the output were perfectly fair. That's the argument for AI literacy. Not in the abstract, we should all understand AI sense. In the very specific sense that the people reviewing AI outputs in your organization need a framework for recognizing these patterns when they appear. Because right now, in most organizations, they are appearing and going unnoticed. Historical bias is shaping who makes it through your hiring funnel. Linguistic bias is disadvantaging people whose English doesn't match a dominant style. Measurement bias is optimizing for the wrong thing in ways that look completely fine from the outside. Automation bias is turning human oversight into a rubber stamp. All of these are solvable training problems. So how will AI literacy solve them? AI literacy isn't about knowing how transformer models work or being able to read a line of Python. It's about knowing what to look for in the outputs your team is already generating and approving every day. If you want to go deeper, the full article on all 5 forms of AI bias is linked in the description. And if you're building AI literacy capability across your team, subscribe for more. See you next time.